You are welcome back to this channel. Good day to you at wherever you are watching this video. I again would plead with you to subscribe to this YouTube channel. Today, under circle theorems, I would like us to look at angles subtended at the circumference of a circle by equal chords or arcs. Look at this beautiful circle on your screen. We have chords CD and chords EF. They are of the same length. As I have already said, in mathematics, when you see lines with equal number of strokes on it or on them, as you see on the screen, it means they are equal. For you to know that really they are equal, look at their lengths. We have line CD, which is called CD, being 4.1, and the length of chord EF being 4.1, so they are equal. I am going to move angle CGD and place it on angle EHF, and we record what happens. Either they would be the same or they wouldn't. Look at how I am moving it and placing it on angle EHF. I hope you finished recording what you observed. We can see that angle CGD fits equally on EHF, and then we can say they are equal. So the property states that equal chords or arcs subtend the same or equal angles at the circumference of the circle. So what the property is saying is that when we have equal chords subtending angles at the circumference of the circle, like you see the beautifully colored angles, then they are equal, and this has been proven. After moving angle CGD on EHF, you saw or you observed that they were equal. So mathematically, we can say that angle CGD is equal to angle EHF. Now there is something I want us to look at. I want to increase the length of one of the chords for you to observe, and you tell what happens. So the chord EF has been increased to 5. That's the length. Let me move angle CGD and see what happens. Look at it well and record your observation. Okay, we can see that for now, because the length of the chords are not equal, angle CGD does not fit equally on angle EHF. As you can see, part of angle EHF appearing on your screen. Okay. Now, let me decrease the length so that it may be equal to that of chord CD, and rather increase the length of chord CD. Okay, now the length of chord CD is 5.2, whilst the length of chord EF is 4.1, as you see on your screen. Now I am going to move angle CGD and place it on angle EHF, and then you record your observation once again. Look at it. You see that angle CGD is now bigger than angle EHF. So this is what happens when the length of the chords are not equal. Then the angles wouldn't also be equal. So let me bring the back. Now the chords have the same length as you see on your screen. And let me bring angle CGD also back. So this is all about the property. Let us look at our questions, solve them for better understanding. Question 1. Find the value of y in the circle above. Let us solve it together. We can say that from the property, angle BAC is equal to angle FDE. And if they are equal, then we can equate these two angles. So bracket open, y plus 20 bracket close degrees is equal to 70 degrees. We have equated these two angles. One can write 70 degrees is equal to bracket open y plus 20 bracket close degrees, and can write it in the other way around. So that is what you see on the screen. Then we have to open brackets so that we get y plus 20 is equal to 70. And then we group like terms. Grouping like terms is not done by magic. We want y to be at the left hand side and we want 20 to be at the right hand side. So because 20 is positive here, we have to subtract 20 from both sides of the equation. And that is also what you see on the screen. And from this, we simplify to get y equals 50, because positive 20 minus 20 would give us 0, and then y would be left at the left hand side. 70 minus 20 would give us 50. So we have y to be 50 as you see on the screen. The question never asks us to find angle FDE, but rather to find the value of y, and that is what has been found on the screen. Therefore, we can say that y is equal to 50. Question 2. Find the value of x in the circle above. Let us solve it together. Picking triangle ABC, we know that the sum of interior angles of a triangle is equal to 180 degrees. We therefore add all the interior angles of triangle ABC, and that is what you see on the screen. Y plus 110 degrees plus 30 degrees is equal to 180 degrees. Then we simplify to get y plus 140 degrees. Well, from the 140 degrees, 110 degrees plus 30 degrees would give us 110 degrees, equal to 180 degrees. Then we have to group like terms. In grouping like terms, since we want 140 degrees to be at the right hand side, we must subtract 140 from both sides of the equation. And that is what you see on the screen. And when we simplify that, we get y at the left hand side, because 140 degrees minus 140 degrees would be 0. 180 degrees minus 140 degrees would be 180 degrees minus 140 degrees. And when we simplify that, we get y equals 40 degrees. But we know from the property that angle BAC, which is y, is equal to angle EDF, which is x. So when we know the value of y, then we can say that s is equal to 40 degrees. Now let us look at the assignment for the day. Look at the diagram well. Find the value of m in the circle with the center O. Pause the video, write your answer down, then you compare your answer to that of mine. From the property, we can say that m is equal to 25 degrees. If you had this, then you are correct. I beg of you again to subscribe to my YouTube channel for more videos. More videos are yet to come, so subscribe for me. May God be with you all till we meet again on this same platform on another day. Bye.